Hello dear students, all of you welcome to Vidyan classes. It is the second lecture on inverse trigonometric functions. Today we will discuss domain range of the basic inverse trigonometric functions. In the first lecture, we have defined the basic inverse trigonometric functions. In lecture number 1, we have discussed sine, inverse, such that close bracket minus 1, 1, close bracket, 2 minus pi by 2, close bracket minus pi by 2, pi by 2, close bracket. Sin inverse x is defined from this set to this set. That means sin inverse is defined from this set to this set. It is the domain set, it is the range set. Cos inverse is defined close bracket minus 1, 1, close bracket, 2, close bracket, 0, pi. And tan inverse is defined from set of real numbers to open bracket minus pi by 2, pi by 2, open bracket. Cot inverse is defined from the set of real numbers to open bracket 0, pi, open bracket. Sec inverse x. Sec inverse is defined from minus infinity to open bracket minus infinity, minus 1, close bracket, union, close bracket 1, to infinity, to close bracket 0, sec 0 is equal to 1. So pi by 2, open bracket, union, open bracket pi by 2, to pi, close bracket. Since sec 0 is equal to 1 and sec pi is equal to minus 1, 0 to pi by 2. At pi by 2, sec inverse x is not defined, that is infinity. And cosec inverse, so that minus infinity to minus 1, close bracket, union, close bracket, 1, to infinity, open bracket, to sin pi by 2 is equal to 1 and sin minus pi by 2 is equal to minus 1, that is close bracket minus pi by 2. At x equal to 0, cosec is not defined, so it is 0, open bracket, union, open bracket 0, to pi by 2, close bracket. In first lecture, we have discussed sin inverse, cos inverse, tan inverse, cot inverse, sec inverse, cosec inverse. Sin inverse is defined from this set to this set, cos is defined from this set to this set, tan inverse is defined from set of real numbers to this set, and cot inverse is defined from set of real numbers to open bracket 0 pi open bracket, and the sec inverse is defined from this set to this set, and the cosec inverse is defined from this set to this set. It is the domain set, it is the range set. It is the domain set or range set. The range is also called principal values. Domain, inverse trigonometric function. We will find out the domain and the range of the basic inverse trigonometric function. These are the basic inverse trigonometric functions. These are the domain sets and these are the range sets. That means when sin inverse operates on this, gives the images this. Cos inverse operates on this set, gives the images as this set. It is the domain set, it is the range set. Inverse trigonometric function. Domain, ITF means inverse trigonometric function. Domain of the inverse trigonometric function. Range or principal values or set of all images. Set of all images is called range. Range or principal values of the inverse trigonometric function or set of all images. First, sin inverse x. It is the domain set. Domain means collection of x values. Sin inverse is defined from this set to this set. So the domain is close bracket -1 and 1. Most important to solve the problems. These are the basic of the inverse trigonometric functions. Domain and range, most important things to solve the problems. What is the range? Close bracket minus pi by 2 close bracket. Sin inverse x operates, sin inverse x gives this. It is the domain set, it is the range set or principal values. Set of all images is called range. Cos inverse x. Cos inverse x is defined from this set to this set. Cos operates on this, gives this. Cos is the function, it is the set of x values. Cos operates on this set, gives this set. Close bracket -1 1. The range set is close bracket 0 pi close bracket. Tan inverse operates on set of real numbers, gives the principal values, open bracket minus pi by 2 plus pi by 2 open bracket. Cut inverse. Cut inverse x means set of real numbers. Cut operates on this set, gives the range that is open bracket 0 pi open bracket. Second verse. Is this set, that is second verse x minus infinity to minus 1 union minus infinity minus 1 close bracket union close bracket 1 to infinity open bracket gives the range that is a set of close bracket 0 pi by 2 0 pi by 2 union pi by 2 open bracket pi by 2 check 0 open bracket pi by 2 to pi 0 to pi by 2 union pi by open bracket pi by 2 to pi. It is a close bracket. And cosec inverse x is the same as this set, that is minus infinity minus 1 close bracket union open bracket close bracket 1 infinity open bracket. This set is same as this set. Close bracket minus pi by 2 cosec pi by 2 is equal to 1 and cosec minus pi by 2 is equal to minus 1. Minus pi by 2 to 0 open bracket union open bracket 0 to pi by 2 close bracket. Very important to solve the problems. These are the basic inverse trigonometric functions. These are the domain sets. These are the range sets. Sin inverse is exist in this interval, gives the range this. Cos inverse x is exist in this interval, gives the range this. Tan inverse operates is exist in R, gives the range that is minus pi by 2 open bracket minus pi by 2 pi by 2. Cut inverse operates on this, gives this. Second inverse operates on this set. These are the domain sets and gives the range. Cosec inverse operates on this set, gives the range this. These are the domain set and these are the range or principal values. Principal values or range or set of all images. When sin inverse operates on this set, gives this. Similarly, we can say for other inverse trigonometric functions. Most important to solve the problems, we have to remember the domain and range or principal values to solve the problems. Clear? In first lecture, we have discussed all basic inverse trigonometric functions. These are the basic inverse trigonometric functions. Very important. Clear? Okay, note down. Next, meaning of inverse trigonometric function. What is the meaning of inverse trigonometric function? It is the graph of y is equal to sin x. X is equal to pi by 2. This line. X is equal to minus pi by 2. This line. This point is minus pi by 2. 0. This point is pi by 2. 0. This point is pi by 2. This 1. This point is minus pi by 2 minus 1. Sin, so that close bracket minus pi by 2 plus pi by 2 close bracket 2 close bracket minus 1 1 close bracket is bijective. In the first class of inverse trigonometric function, we have discussed the sine function defined from this set to this set is bijective. Since the function is 1 1 and 1 2, in this interval, the function is increasing. Every increasing function is 1 1. Since the range of the function is equal to codomain set, it is on 2. As the function is 1 1 and on 2, the function is bijective. Clear? Every bijective function has the inverse. Implies by sin inverse is exist and sin inverse such that close bracket minus 1 1 2 close bracket minus pi by 2 plus pi by 2. Sin is the function defined from this to this. Since it is bijective, its inverse is exist. The inverse function is defined from this set to this set. All are discussed in the previous classes. Sin inverse is exist. What is the meaning of this? Sin operates on pi by 2 gives 1. Sin operates on minus pi by 2 gives minus 1. Similarly, sin inverse operates on minus 1 gives minus pi by 2. Sin operates on 1 gives pi by 2. Here, sin inverse 1 is equal to pi by 2. Is a radian angle. Sin inverse operates on 1 gives pi by 2. Sin inverse operates on minus 1 gives minus pi by 2. Sin inverse minus 1 is equal to minus pi by 2. Is a radian angle. Sin inverse 1 is a radian angle. Sin inverse minus 1 is a radian angle. In general, we can say Sin inverse x. Sin inverse x represent x means 1, minus half, plus half, etc. Sin inverse x represent the radian. Sin inverse x represent the radian angles for all x belongs to close bracket minus 1, 1. As sin inverse 1 is equal to pi by 2, sin inverse minus 1 is equal to minus pi by 2. All are radian angles. Sin inverse x represent the radian angles for all x belongs to close bracket minus 1, 1 close bracket. Second condition, sin inverse x gives the principal values. Sin inverse x gives the principal values or range for all x belongs to close bracket minus 1, 1. Sin inverse x gives the principal values or range for all x. When x varies in this set, we will get different values of sin inverse x. These are called the principal values. Clear? Very, very important. From the above discussion, it is clear that most important, similarly we can show that every sin inverse x represent the radian angle. Similarly, we can say cos inverse x represent the radian angle, tan inverse x represent the radian angle, cosec inverse x represent the radian angle. Similarly, we can show that every inverse trigonometric function represent a radian angle. Most important, every inverse trigonometric function represent a radian angle, and this sin inverse x represent the radian angles. Sin inverse x gives the principal values when x varies in this set. As sin inverse 1 is equal to pi by 2 is a radian angle, x is 1 and x is equal to minus 1. Sin inverse minus 1 is equal to minus pi by 2 is a radian angle. Example, find the principal values of sin inverse sin 5 pi by 6. Sine function is bijective when it is defined from this set to this set. Here 5 pi by 6 is not belongs to this. Sine 5 pi by 6 is not belongs to this set. We have to find out sine 5 pi by 6 in terms of the elements which belongs to this set. For example, answer sine inverse sine 5 pi by 6, which is same as sine inverse sine pi minus pi by 6, which is same as sine inverse 6 pi minus pi, that is 5 pi by 6. Sine pi minus theta is equal to sine pi minus theta is equal to sine theta. Five pi by 6 not belongs to close bracket minus pi by 2 plus pi by 2 close bracket, but pi by 6 belongs to minus pi by 2 and pi by 2. So sine 5 pi by 6 and sine pi by 6 have the same value. Sine 5 pi by 6 is same as sine pi minus pi by 6. Sine pi minus theta is equal to sine theta. The sine function is bijective when x belongs to this set. Here x is equal to 5 by 6 not belongs to this set. So we will change to 5 pi by 6 to 5 pi by 6. Here pi by 6 belongs to this, which is equal to sine inverse sine 30 degree, that means half. Every inverse trigonometric function represent a radian angle. Sine inverse half represent a radian angle. Sine inverse half is equal to theta. Theta is measured in radian. What is the value of this? Every inverse trigonometric function represent an angle. Sine inverse half is equal to theta. Since sine function is bijective from this set to this set, we can write sine inverse is defined from this set to this set. We can write sine is defined from this set to this set. If f is a function from a to b is bijective, y is equal to fx, that implies and implied by x equal to f inverse y. Since it is bijective, its inverse is exist, implies and implied by sine theta is equal to half, which is equal to sine pi by 6. Since sine function is bijective when it is defined from this set to this set. Theta is equal to sine theta is equal to sine pi by 6, theta is equal to pi by 6. What is theta? What is the value of theta? Theta is taken by sine inverse half is equal to pi by 6. So this value is pi by 6. Inverse trigonometric function represent the radian angle. Represent a radian angle. What is the meaning of this? Sine inverse 1 is equal to pi by 2. Directly we can find out the result. Sine inverse 1 is equal to pi by 2. Sine of which angle gives 1? Sine of which angle? Sine inverse 1 means sine of which angle gives pi by 2. Sine of which angle gives 1, that is pi by 2. Sine of which angle gives minus 1, that is minus pi by 2. Similarly, sine of which angle gives half, that is pi by 6. Pi by 6 belongs to this set, pi by 2 belongs to this set, minus pi by 2 belongs to this set. Since sine function is bijective when it is defined from this set to this set. Clear? What is the meaning of? Similarly, we can write cos inverse 1. What is the value of this? Directly we can find out. Cos of which angle gives 1, that is 0. That is 0. Sin inverse root 3 by 2. Sine of which angle gives root 3 by 2, that is pi by 3. That means 60 degree. Sine of which angle gives root 3 by 2, that is pi by 3. Sin 60 degree is equal to root 3 by 2. Inverse trigonometric function represent a radian angle. In every inverse trigonometric function represent a radian angle. This conclusion helps to solve the problems. Plus inverse 1. You ask cos of which angle? Cos of which angle gives 1, that is 0, radian. Sine of which angle gives root 3 by 2, that is pi by 3, that means 60 degree. Sin 60 degree is equal to root 3 by 2. Sin inverse 1 means sine of which angle gives 1, that is pi by 2. Sine of which angle gives minus 1, that is minus pi by 2. Clear? What is the meaning of inverse trigonometric function? It represents a radian angle. It represents a radian angle. Are you clear? Okay, note down. Next question. Find the principal value of the following inverse trigonometric functions. First bit, sin inverse cos sin inverse root 3 by 2. Since sin, so that close bracket minus of pi by 2 close bracket minus pi by 2 plus pi by 2 close bracket 2 close bracket minus 1 is bijective. Bijective means 1 1 and on 2. That means the function is invertible. Every bijective function has the inverse. Implies by sin inverse is exist and the sin inverse is defined. Close bracket minus 1 1 close bracket 2 close bracket minus pi by 2 plus pi by 2 close bracket. Since sin function defined from this set to this set is bijective, its inverse is exist and sin inverse is defined from this set to this set. If f is a function from a to b is bijective, then its inverse, that is f to the minus 1, represent the inverse defined from B to A to B, B to A. Sin inverse cos sin inverse root 3 by 2. Sin inverse cos sin inverse root 3 by 2. What is the meaning of a sin inverse root 3 by 2? Every inverse trigonometric function represent a radian angle. So sin inverse root 3 by 2 represent a radian angle. Sin inverse root 3 by 2 means it represent for which angle of a side, that belongs to this set having value root 3 by 2. This represent which angle of a side that belongs to this set. Since sin inverse is defined from this set to this set, which angle of a side that belongs to this set having value root 3 by 2. It represent pi by 3. Since sin is 60 degree is root 3 by 2. Sin 60 degree is root 3 by 2. It represent a radian angle. Which angle of a side that belongs to this set having value root 3 by 2 implies pi by 3. Cos 60 degree is half. Cos 60 degree is half. Now it represents a radian angle. Which angle of a side that belongs to this set having value half? It represents pi by 6. That means 30 degree. So the principal value of sin inverse cos sin inverse root 3 by 2 is pi by 6 is the answer. Second bit, tan inverse tan 3 pi by 4. Tan inverse tan 3 pi by 4. What is the principal value of the inverse trigonometric function? Since tan that open bracket minus pi by 2 plus pi by 2 open bracket to set up real numbers is bijective. When tan is defined from this set to this set, it is bijective, which implies by its inverse is exist and tan inverse, so that tan is defined from this set to this set, its inverse is defined from this set to this set. That means set up real numbers to open bracket minus pi by 2 plus pi by 2. When y is equal to tan x is defined from this set to this set, that means open bracket minus pi by 2 plus pi by 2 open bracket to set up real numbers. The function is bijective. Every bijective function is invertible. That means its inverse is exists. Tan inverse is defined from this set to this set. Here 3 pi by 4 not belongs to minus pi by 2 plus pi by 2. So we can write tan inverse tan pi minus pi by 4. 3 pi by 4 can be written as pi minus pi by 4. Tan pi minus theta. Tan pi minus theta is equal to minus tan theta. Theta means pi by 4, which is same as tan inverse tan 45 degree 1. So it is minus 1. Tan inverse minus 1. It represents a radian angle. Since every inverse trigonometric function represents a radian angle. Tan inverse minus 1. Tan inverse is defined from this set to this set. Which angle of tan that belongs to this set having value minus 1? Which value of tan? Which angle of tan that belongs to this set having value, it represent an angle. Which angle of tan that belongs to this set having value minus 1? Having value minus 1. That is minus pi by 4. Which angle of tan that belongs to this set having value minus 1? That is tan minus pi by 4. Tan inverse minus 1 is equal to minus pi by 4. Since tan minus pi by 4 is equal to minus tan pi by 4, tan minus theta is equal to minus tan theta, which is equal to minus 1. Which angle of tan that belongs to this set, which belongs to this set having value minus 1, that is minus pi by 4. Since tan minus pi by 4 which is equal to minus tan pi by 4, tan minus theta is equal to minus tan theta, tan pi by 4 is equal to 1. Tan inverse minus 1 represent a radian angle. It represents a radian angle. Which angle of tan that belongs to this set having value minus 1 implies as minus pi by 4. Clear? Clear? Okay, note down. Next question. Find the value of cos tan inverse cos inverse root 3 by 2. Second bit sin cos inverse tan sec inverse root 2. First bit solution. Cos tan inverse cot cos inverse root 3 by 2. Here tan inverse and cos inverse are exist. At what condition the inverse of tan and cos are exist? Cos so that close bracket 0 pi close bracket 2 close bracket minus 1 1 close bracket is bijective. Bijective, that is the cos function is bijective when it is defined from this set to this set. Implies and implied by every bijective function has the inverse. Every bijective function has the inverse. So cos inverse x is exist and cos inverse so that close bracket minus 1 close bracket 2 close bracket 0 pi close bracket. Cos inverse is exist. It is defined from this set to this set. Tan so that open bracket minus pi by 2 plus pi by 2 open bracket 2 set up for real numbers is bijective. Tan is bijective when it is defined from this set to this set. Its inverse is exist and tan inverse so that set up for real numbers to open bracket minus pi by 2 plus pi by 2 open bracket. Now cos tan inverse cos inverse root 3 by 2. What is the meaning of this? Cos inverse root 3 by 2 represent a radian angle. Since every inverse trigonometric functions represent a radian angle, cos inverse root 3 by 2, it implies this. For which angle that belongs to this set, for which angle that belongs to close bracket 0 pi close bracket, for which angle that belongs to this set having value root 3 by 2, having value root 3 by 2, but for which angle that belongs to this whose cos value is root 3 by 2. Cos 30 degree, cos 30 degree is equal to root 3 by 2. This represents a radian angle, for which angle that belongs to this set having cos value root 3 by 2. Cos 30 degree is equal to root 3 by 2, which is same as cos tan inverse cot 30 degree. Tan 30 degree is equal to 1 by root 3. Cot 30 degree is equal to root 3. Now tan inverse root 3. It represents a radian angle. This represents a radian angle. For which angle that belongs to this set having tan value root 3. It represents a radian angle, for which angle that belongs to this set having tan value root 3. Tan 60 degree is equal to root 3. That means pi by 3. 60 degree. Tan 60 degree is equal to root 3. Now cos 60 degree is equal to half. Clear? Next, second bit. Solution. Sin cos inverse tan sec inverse since sec so that close bracket 0 pi by 2 open bracket union open bracket pi by 2 pi close bracket 2 minus infinity open bracket minus infinity minus 1 close bracket union close bracket 1 infinity open bracket is bijective. Bijective implies and implies by its inverse is exist. In this interval, in first class we have discussed. Sec function is bijective when it is defined from this set to this set. Implies and implies by sec inverse is exist and sec inverse such that open bracket minus infinity minus 1 close bracket union close bracket 1 infinity open bracket 2 close bracket 0 pi by 2 open bracket union pi by 2 open bracket pi by 2 pi close bracket. Clear? Sec function is bijective when it defined from this set to this set. Sec inverse root 2 represent a radian angle for which angle that belongs to this set having sec value root 2 sin cos inverse tan for which angle that belongs to this set having sec value root 2 that is pi by 4. Cos pi by 4 is equal to 1 by root 2, sec pi by 4 is equal to root 2. Tan pi by 4 is equal to 1. Now it is a radian angle. For which angle that belongs to cos inverse is defined from this to this belongs to this set having cos value 1 cos 0 is equal to 1 is equal to sin 0 sin 0 is equal to 0 is the answer. Clear? Are you clear? Okay. Note down.